You've seen how to add, subtract, multiply, and divide rational numbers. You have also seen how to simplify expressions with rational numbers. In this video, we look at using rational numbers to graph points on the Cartesian coordinate plane. Let's start with an example. Find the slope of the line that passes through point A and some random point B. Write the slope as a rational expression, then find the equation that has a slope of 5. Point A has specific coordinates. Given the location of the point, we can see that it has coordinates 1.5, 2, as shown here. That means we count 1.5 units along the positive x-axis and 2 units up on the positive y-axis. We're also told that B is a random point, meaning that it doesn't have specific coordinates. So we label the coordinates for B as x, y, as shown here. To find the slope of the line connecting these 2 points, we use the slope formula, as shown here. Let's assign x1 and y1 to point A, and x2 and y2 to point B. Plug their corresponding values into the slope formula, as shown here. This is the slope of the line that crosses A and B, where A is a specific point and B is a random point. This is a rational expression, which in this case means that it is a ratio of 2 linear expressions. Next, we're told to find the equation of the line that has a slope of 5. In this case, we are given the slope, so we make the slope equal to this rational expression, as shown here. 5 is equal to the rational expression of y minus 2 over x minus 1.5. We want to rewrite this as an equation of the form y equals the term on the right. To start, we multiply both sides by the quantity x minus 1.5. We get 5 times that expression on the left, and on the right, that expression divides out, so we are left with this equation. We distribute the 5 across the 2 terms to get 5x minus 5 times 1.5 on the left and y minus 2 on the right. We simplify the term on the left to get 5x minus 7.5. Because we want the equation to have y on the left side, we swap the terms on the left and right as shown here. Now, all we need to do is add 2 to both sides. We get y equals 5x minus 7.5 plus 2, which simplifies to y equals 5x minus 5.5. This is the equation of the line with a slope of 5, as shown here, that passes through point 8 with coordinates 1.5 and 2. Let's look at another example. Express the slope of the line connecting points A and B as the ratio of 2 differences. Under what conditions are slopes positive, negative, or 0? We know that the slope of the line connecting any 2 points can be found using the slope formula. But in this case, we aren't given the coordinates. So we can use a variation of this formula as shown here. The change in x coordinates we designate as delta x. The change in y coordinates we designate as delta y. The slope is the ratio of delta y over delta x. There are several cases to look at. The first case, shown here, is when point A and B are arranged so that B is up and to the right of A. In such a case, the slope is positive. The values of delta y and delta x are either both positive or both negative. In either case, the slope is positive. Also, A and B can be in different quadrants from what's shown here. This is one possibility, as is this one. There are other possible configurations. So long as point B is up and to the right of A, the slope is positive. Another case is where B is to the right and below A, as shown here. In this case, the slope of the line connecting these 2 points is negative. This means that either delta y is positive and delta x is negative, or delta y is negative and delta x is positive, as shown here. Also, A and B can be in different quadrants, not just in the configuration shown here. Here are some other possibilities. So long as B is to the right and below A, the slope is negative. There is a third case where A and B are collinear along a horizontal line, as shown here. Delta x is clearly shown, but what is delta y? Since both points have the same y-coordinate, then delta y is equal to 0. Since slope is delta y over delta x, and since delta y is 0, then the slope is 0. Basically, all flat lines have a slope of 0. Finally, there's the case where A and B are collinear along a vertical line. In this case, delta y is easily seen, but there is no delta x. In other words, delta x is equal to 0. Because the slope formula involves division by delta x, and since division by 0 is undefined, then a vertical line has an undefined slope or no slope.